intro just gets weirder and weirder every time I see it. Hey, anyway, glad to have you here this week. We've got that test behind us, that mid-unit test that we were trying to do to shorten how much we are testing you over for this unit. We're on quadratics. That's the last stuff we're covering this year. So what we're kind of planning on now is we've got that mid-unit test. We're going to finish up quadratics and try not to take the rest of the year. We're going to try to have some time where we'll go back and pick up some things that we knew earlier, just to kind of refresh those and have those ready for you moving into next year. So hopefully we won't spend another 4 or 5 weeks on quadratics. Maybe we can shorten up the last part of it, because we're going to get to the best part of it today. I'm excited about today's lesson. Stay tuned for our story about this. We are moving on to the quadratic formula. Before I get to that, I want to mention the test just a moment or two. I think it graded on formative at like 35 points. I don't know if I'm going to put it in the grade book for that, because not all of those are really learning targets that we were testing on. Like I put the question in there where you had the problem that started out here and the girl had factored it for us, and then it asked you, why does that help to factor it to find the solution? And a lot of you guys are like, well, it's just simpler, it's easier to look at and all that, which is telling me you don't really know why you factor it. And I could tell that when I saw the way a lot of you did problems. Some of them I gave you a factored equation. Here is x plus 3 times 2x plus 9 equals 0. Solve. And you would multiply those back together in the standard. And I went, okay. And then the next step is you factored them again. Yeah, because you can't solve it unless it's factored. So it's factored so we can set those factors each equal to 0. When we get it factored and get it equal to 0, one of those factors has to be a 0. So the reason we factor it is so we can actually find what x is. Set the factors equal to 0 and solve. Because when it's still in like x squared plus x, we're like guess and check. We can do that. But we needed it factored. So you're like, well, it's just easier to look at. It's simpler. No, it's how you solve it. You factor it and then set those factors equal to 0. So I saw a lot of confusion with that. But now, after today, you won't have to factor it if you don't want to, because we are going to learn the quadratic formula. Probably the biggest tool that we're going to have in our math tool belt that we've built this year is the quadratic formula. And you can solve whatever quadratic equation you got it right here. So, in fact, I had a professor back when I went and got my bachelor's degree, a couple of lifetimes ago, whatever that was. I had a professor in the math department, Dr. Chen. I loved Dr. Chen. He was from China and still had a very heavy accent, and so sometimes it was kind of hard to understand him, but he was very entertaining. He's very knowledgeable. Sometimes he had trouble explaining it to us because of how much he knew about it, but he liked the quadratic formula. In fact, he had a story about the quadratic formula that he told us. Let's see, what was that Dr. Chen said? Alexander the Great, he lived thousands of years ago, and he was a great conqueror. And he went and conquered the countries around him. He conquered that country, and then he conquered another country, and then he conquered another country until he had conquered all the countries of the world. Then he went back home. His friends came over to celebrate, and Alexander was like, boo-hoo, boo-hoo. His friends are like, Alexander, why you cry? You conquer all the countries in the world. And Alexander say, boo-hoo, I cry because there are no countries left to conquer. Well, with the quadratic formula, you can cry too, because there will be no equation that you cannot solve. I'm going to need a moment. That was beautiful. That was beautiful. All right. Yes, thank you, Dr. Chen. I still remember that story. That was just, all my college years, you're one of the few professors I can still remember by name and some of the stuff he did in class. And that was an awesome story. I don't know how many times I've told that in all the years, but I love that story, Dr. Chen. Thank you. So today we're going to put that tool in our tool belt. So grab your Kleenex and be ready to cry, because we're going to learn the quadratic formula today. All right, let's get to it. All right, so this is our introduction to the quadratic formula today. We're going to start out with just making sure we understand how to do some of the components here. 1 plus or minus 49. What is the square? The 1 plus or minus the square root of 49. What is the square root of 49? Well, it's 7 or negative 7. But since we're taking the plus or minus of either one of them, we only have to use just the 7. Because if we did plus 7 or minus 7 and then said plus negative 7 and minus negative 7, we end up with the same numbers twice. So when you have something like this with the quadratic formula, we're only looking for the positive value, because we're going to take both situations, whether it's positive or whether it's negative. So 1 plus 7 and 1 minus 7. So this will equal 8 or negative 6. So that has two answers. 1 plus or minus the square root of 49 would either be 8 or it would be negative 6. How about this? 8 plus or minus 2 divided by 5. Well, 8 plus 2, so it's saying two different things at the same time. It's saying 8 plus 2 over 5, and it's saying 8 minus 2 over 5. We're talking about both of those numbers. So 8 plus 2 is 10 divided by 5, so that answers 2. 8 minus 2 is 6. 6 divided by 5 is, we'll just say 6/5. Don't have to get a calculator out. Don't have to do any of that. We can just call it 6/5. How about this? Man, what a mess that looks like, right? One step at a time. Very simple. We do the underneath the radical, we do the exponent first. There's nothing in the parentheses other than a number, so we don't have to worry about that. But negative 5 squared. So negative 5 times negative 5. Well, let's see. So we're looking at the square root of 25. All right, 25. Minus 4 times 4 times 1. We're just multiplying three numbers together. And in this case, one of them happens to be a 1. So 4 times 4 times 1, well, that's minus 16 then, see? So we have 25 minus 16. And plus or minus out front. So what is 25 minus 16? 25 minus 16 is 9. So we're looking at plus or minus the square root of 9. So the answers are 3, negative 3. Right? Or plus or minus 3. Same thing. Plus or minus 3. We're looking at 3 or negative 3. That's what all of that boiled down to. And finally, let's look at this one down here. Negative, let me turn this a little bit. Make sure we got room to see all this. Negative 18 plus or minus the square root of 36 over 2 times 3. Okay, we're just putting a lot of this all together. We've got a lot to deal with on this one. We can do this. So if we do that, let's say negative 18 plus or minus the square root of 36. What is the square root of 36? Well, it's 6, right? So we're looking at negative 18 plus 6 over, what's 2 times 3? Yeah, 6. Or we're also looking at negative 18 minus 6 over 6. So we just took this and broke it out into two different answers, because one of them is adding, one of them is subtracting. Two different answers. Negative 18 plus 6, that's negative 12. Negative 12 divided by 6, negative 2. So that's one of the answers. Negative 18 minus 6 more. Now we're at negative 24 divided by 6, negative 4. That is the two answers there. So it's just stepping through. I mean, it looks like a lot there, but we just do it piece by piece. We don't have to do anything with that. We got to figure out what this is so we can add or subtract it, and then 2 times 3 on the bottom. So step by step. We're not doing it all just like bam at one time. So, all right, let's look at this. Now this says choose one equation to solve. That's good, because I see a lot of work there with 4 equations. It says we can choose any one we want. We can either rewrite it in factored form, or we can complete the square. And let's explain our method of choice. Our choice of method of choice. Let's see, what one do you want to pick? Let's try this one. Let's try that. 5x squared. Let's try factoring, because it's equal to 0, and we have to rearrange. We have to get it equal to 0 so we can set the factors equal to 0. So Let's take that one and we'll say, okay, well, 5x squared. I like that because there's only one combination, 5 times 1. There's not anything else we can do that. So it has to be an x and it has to be a 5x. No choices there, right? No choices. And this is a minus and this is a plus, which means one of these is going to be a plus and one of those is going to be a minus. And we need the bigger number to be the plus. And it has to multiply to be negative 44. So what multiplies to be 44? 1 and 44, 2 and 22, 4 and 11. You think of anything else? That's about it. We have 3 choices. So we know the bigger one has to be positive. Now, if it's close enough, and one of them is going to be multiplied by 5. So if we multiply this by 5, it would be the bigger one. But if we multiply this by 5, it's still smaller. So in 2 of these, the 22 and the 44 can go anywhere. But they have to end up being the positive one. But this could be the positive if it's multiplied by 5. So let's see, we got to end up with a 9. Got to end up with a 9. Well, if we use a 44, right, a 44 there, it'd be multiplied by 5. It'd be over 200, and the other one's just a 1. We're not going to be anywhere near 9. So what if we put it with the 5? Put the plus 44 there. So then you got 44 times x and 1 times 5. Negative. It has to be a negative 1, sorry, because one's going to be positive, one's going to be negative. Well, that's plus 44 minus 5. That's not going to be 9. That's going to be 39. So 1 and 44 doesn't work. How about 2 and 22? All right, so if we put the negative 2 here, this is going to be a lot closer now. So 22 times x and negative 2 times 5x, that's negative 10x. So we've got 22x and negative 10x. It's still 12x. 22 minus 10 is 12, not 9. That doesn't work either. If we switch them the other way, it'd be multiplying 5 times 22 and put us over 100. So that's not going to be any closer. Okay, so that didn't work. So that tells us there's only one option left, but it could go either way. So let's look at that. Minus 4 times 11. Well, this would be negative 4 times 5 is negative 20, and this is 11. 20 minus 11 is 9, but it was negative 20. So let's see. Let's change this to the positive and that to the negative. And now we've got 20x right there, and the outside is multiplied to negative 11x, 9x. Okay, there is the factors. It just took a lot of trial and error jumping through there trying to figure out what it was. 9x. And then it says solve. We got to x plus 4 equals 0. This is why we put it in factored form, so we can actually solve it. Minus 4, x equals minus 4. 5x minus 11 equals 0. 5x minus 11 equals 0. Add 11. 5x equals 11. Divide by 5. X equals 11 fifths. Whew. Boy, good thing we didn't try guess and check. Would you have ever guessed 2.2 is an answer? 11 fifths. We have a negative 4 and 11 fifths. That worked out nicely. This is using decimals there. This, I don't even think either one of the answers are going to be something easy to calculate. So you get into some tougher quadratic problems. And factoring, this was probably the easiest one of those 4, and I kind of chose that so we wouldn't spend so much time on it. Some of these we would probably never come up with the answer because it's not just like a 1 decimal. Some of them like 0.375 type stuff. And when you get to those, that's where that quadratic formula is going to bail us out, right? Because we could solve any of these with the quadratic formula. So what is the quadratic formula? A couple of you guys have found this on your own. Some of you were looking it up online, and I've seen some of you use it. Meet the quadratic formula. There it is. This is the quadratic formula. I put it in big, big letters here. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. And like, what is this ABC? We're just using that for any equation. So as long as the equation looks like this, ax squared plus bx plus c equals 0, that's where we get our a that goes there, and our b that goes there, and our c that's used right there. So whatever those numbers are. So like in this one that we did here, a would be 5, b would be 9, and c would be negative 44. See where we get that, the a, b, and the c? We just take this and say, what is the x squared coefficient? What is the number in front of the x squared? That is our a. What is the number in front of the linear, just the x? That would be our b. And then what's the constant that does not have a variable? That's the c. So that is the quadratic formula, and we are going to use that in today's homework. In the homework assignment, it's going to have solve this by the quadratic formula. That's a show your work thing where you need to either do it on paper and upload an image, or you can use the writing tools on there to do all of this. And let me see you practice using the quadratic formula. But we're going to practice it together first. All right, so I'm going to go to the next page. All right, oh, here's an example. Here's one in action. All right, so we're going to walk through this. All right, let's do this. Let's go through it one step at a time. So this shows how the quadratic formula is used to solve x squared minus 8x plus 15 equals 0. All right, so we got to have this way. If our equation is not set up that way, maybe it's negative 15 on the other side of the equal sign, we will need to add 15 to both sides and move that over because we want it to be equal to 0 for the quadratic formula to work. So here's our equation. So that means a, all right, we're looking for that a. A right there is 1. That would be whatever goes with the x squared, which is just a 1. There's nothing there. The b is negative 8. So we'll see it negative 8. And that's the negative 8 that goes with the x right there. And then c is the 15. We see that plus 15 added on. And that goes right there with c. So that's where a, b, and c comes from. Right there in the equation. So here's the quadratic formula again. All right, I just repeated the formula as it was. Now all I'm doing, first step, substitute a, b, and c into the formula. So we see that same a was 1, so that went right there and right there. That's where the a's were, all right, because that's where we saw a in the quadratic formula. For the b's, there's a b here and here, so we're going to substitute negative 8 and negative 8 in both of those. Notice they're in parentheses because we don't want to lose that negative with what we're going to do in this math. And then c just has that one spot and it goes right there. So the 4 and the 2 are part of the formula. That doesn't change. Minus 4. It's minus 4 times AC. But we're just simply substituting in. That's always the first step. Put the numbers into the formula that you need. All right. So then, now you're just evaluating everything. What is minus negative 8? It's 8. Okay, that's all we did with that. Then we go plus or minus. What's underneath the radical? What's underneath the square root? Negative 8 squared. What is negative 8 times negative 8? Positive 64. That was one of those things where we just put minus 8 squared in the calculator and it said negative 64. It's because you got to have that parentheses, just like it's shown on the paper. If you don't have negative 8 squared, it's not going to grab the negative until it's done. It's going to take 8 squared and then put a negative on it. Positive 64. Over here, minus 4 times 1 times 15. Well, 4 times 1 is just 4. So 4 times 15 is 60. So underneath the radical, we have 64 minus 60. And then the bottom is 2 times 1, just divided by 2. So we just evaluate it. That's all we're doing with that. Let's see. Next, we're going to simplify this. 64 minus 60, that's 4. So that's all we did. 8 plus or minus 4 divided by 2. So that means square root of 4 is just 2. Sometimes this is a number. Square root of 4, it's 2. Sometimes it's not. You may get the square root of 11. If it's the square root of 11, you leave it as the square root of 11. We're not going to put it in the decimal. We're going to leave it. 8 plus or minus 2. So that means that is either 8 plus 2, which is 10 divided by 2, or it's also the other solution, two solutions, 8 minus 2, which is 6 over 2. So the two solutions are 5 and 3 for that equation up there. 5 and 3. So that's how that works. We just substitute and then we just do the math. And it's back to your elementary school math for the most part. It's multiplying, it's adding, it's subtracting. And then we do have that one square root that we have in there towards the end there that we do. So here are two quadratic equations. And I have the solutions. That way we know if we did it right. But we want to use the quadratic formula to show that these solutions are correct, right? That we can get the same answers. X squared plus 7x plus 12 equals 0. So first, let's identify what is our A. A is what the coefficient of the x squared is. A is 1. What is B? It's the coefficient of the x term. It's 7. And then C is the constant, so it's 12. And in this case, they're all positives. All positive numbers. So, our quadratic formula, let me pull it back up here for everybody. Put it right there at the top. So, our formula is x equals negative b. What's our b? B is 7. So we're going to say it's negative 7. I'm going to put this big line across there. Plus or minus the square root of, then what do we have? B squared. 7 squared. Now we can write 7 squared, or we can skip that step if you want to go ahead and put what that is. 7 times 7 is 49, because we're going to need to know that anyway. So 49, b squared, minus 4 times a times c, times 1 times 12, times 1 times 12. All right? And at the bottom is 2 times a. A is 1, so 2 times 1 is just 2. All right, we've got it set up. We've done our substitution. Now let's just do the math. So, nothing to do there. We already did that. Minus 7 plus or minus the square root of. What is 4 times 1 times 12? 4 times 1 is 4. 4 times 12 is 48. So 49 minus 48. I'll go ahead and write that for this step. All that divided by 2. All that divided by 2. So continuing to simplify. So x equals negative 7 plus or minus. What's 49 minus 48? It's 1. What's the square root of 1? It's just 1. 1 times 1. So plus or minus 1 divided by 2. Hey, we're getting real close. So the solution is either negative 7 plus 1 divided by 2, or it's negative 7 minus 1. After we get down to this part, we're going to divide it into two separate ones. We're not going to leave it plus or minus. Negative 7 plus 1 is negative 6. So that answer is negative 3 when we divide it by 2. Negative 7 minus 1 is negative 8. We divide that, negative 4. So it said our solutions were negative 3 and negative 4, so we must have done that correctly. Must have made it to the end correctly there. So here's our last problem we're going to try, and then I'm going to turn you loose on the homework and give it a try. If you have problems with it, come see me. I'll post my hours. They're going to change a little bit week to week. I adjust them as I need, as I have other things that I have commitments for, other different things. But let's try this one. Look at this. It says the solutions are 4 plus or minus the square root of 20 over 2. Wow. So they've done some simplifying. Now, we may end up with like 8 plus or minus 20 over, all of it divided by 2. They've already taken the 8 and divided by 2 and separated that. You don't have to take that step. We'll get there, and we'll see if we have an equivalent answer. Okay. So our A, again, just 1. Okay. Our B, got to pay attention. Our B is a negative this time. It's a negative 8. And our C is 11. All right, let's substitute it in. So we've got x equals negative B. negative -8. So that would make that a positive 8 plus or minus square root of b squared, right, which is -8. -8 times -8, 64 minus 4 times a, which is 1. So we'll just multiply it by c now. 1 times c, 1 times 11. So 4 times 11 all over 2 times a. 2 times 1, 2. All right, so let's simplify this. 4 times 11 is how much? 44. 64 minus 44. So that's the same as 8 plus or minus the square root of 20, because 64 minus 44 is 20, all divided by 2. That is the same answer as this. What they've done is they took this part and said, well, 8 divided by 2 is 4, so we can take that out from the parentheses, but we can't divide the square root of 20 by the 2 unless we want to simplify the radical, which we won't get into that. That's a whole nother lesson in simplifying the radical. So this answer is fine. You don't have to simplify it beyond that. In fact, it's probably easier not to. You might have some problems. But if you can do that, it's fine to go ahead and simplify it that way. To actually figure out what that number is, we just put the square root of 20 in a calculator, and it's going to be 4 point something, right? 4 point something divided by 2. So that means when you divide by 2, it's going to be 2 point something. So it's either going to be 4 plus 2 point something, 6 and change, or 4 minus 2 point something. So it's going to be 1 point something. So as a number, as a decimal, it's going to be somewhere between 1 and 2, and somewhere between 6 and 7 is our two solutions. But this is exactly what our solution is. Okay, so all right, this is how you do it. You can do this. Just take your time, substitute. If you substitute properly, then it's just a matter of just simplifying and doing the math as you go through. So let me know if you got problems. We're online. We're here to help you. Love talking to you. Enjoyed chatting with those of you who've come on, and it's just nice to see your faces, hear your voices, any of that, and do work you can be proud of.